Part 3, expanding binomials. You're going to notice that maybe Miss Chang should have done this example for you first. But I want to give you a different way of asking the same question, okay? Number 46 says, expand the binomial. This is a binomial. There's two terms, right? Using Pascal's triangle to determine the coefficients. Now, from the Pascal's triangle, you already know that this is going to be 1, 5, 10, 10, 5, 1. Symmetric, right? You already know that. So how do we use that? This is a much easier example. So if you didn't understand the last example, don't worry so much, because if I explain this one, you're going to understand it, okay? That's number 34 that we did earlier, right? That was a confusing one. So here, you guys, let's actually write the binomials down. So I won't do all the craziness, because let's do this one in a simpler way. You know that the coefficient is 1. I won't write out all the little nuanced parts of what you're supposed to do here. We know that Pascal's triangle says 1, 5, 10, 10, 5, and 1, right? We know that, okay? So how do we fit the rest of it in? Remember, it's your A and the B, right? Or your X and the Y. But your Y is actually 2Y. So in here, you're going to put what? X to the 5th, because the 2y is to the 0 power, right? Let's put that here. And you know your next coefficient is 5. But what goes here? The x to be 4, right? Because x decreases. And you have your 2y to be your first one here. That has to add up to 5, right? What goes here? 10, x to the 3rd, right? And then your 2y is going to be to the 2nd power. Okay? 10, x to the decreases 2, y to the, to 2y. I'm going to erase the rest of it here for now, sorry. Okay, 2y to the, this is 2, so this should be 1. Oh, sorry, this should be 3, because we're going up on the y, okay? Plus 5 times x to the 1 and y to the 4th, right? 2y to the 4th. Plus 1 x to the 0, 2y to the 5th. So we're using the coefficients here, okay? Then let's simplify. Then we get x to the 5th. What do we get here? Plus 10x 4th, y1. Plus 10, 4. So 40x cubed, y squared. Plus 80, because this is 8, 2 to the cube is 8 times 10 is 10. 10 is 80. X squared, y cubed. And they all add up to 5, right? 5, 5. Plus 5x, oh, I'm sorry, not 5. It's 16 times 5, right? So it's going to be another 80 here. X, y to the 4th. Because 2 to the 4th and times 5. Plus just 32. And x is gone because x becomes 1, y to the 5th, okay? So hopefully that example helped a little bit, okay? I know you could be a little bit confused, but there's just different ways to ask the same question, okay? Let's go to the next one. So I can ask you questions like this. What is the 3rd term for this expansion? In which case, you'd be like this. What if I asked you, what's the 4th coefficient? The coefficient of the 4th term in this expansion? It'd be 80, like that, okay? How about here? Find the coefficient A of the given term in the expansion of the binomial. Oh my god, this is this. That means if you're thinking about Pascal's triangle, it goes down 11 rows, right? And this is this term. But I know what you're thinking. You're thinking, but 8 and 6 don't even add up to 10. Oh, I wonder why. So think about that. When you're ready to listen, listen. 8 and 6 exceed 10. I thought they had to always add up to the end. But you can see that this 2 here, this 2 kind of affects that, okay? So think about it, okay? Think about it. X8, Y6. In our case, what does that mean, right? How do we get that 8? But our first term is x squared. You're right. Multiply by 4 there. And then Y6 stays the same, okay? So think about it. Now, all we have to focus on are these exponents. So this is a 10th, right? So isn't it 10 choose 6? So that's the 11th row, 7th term. So if you want to write out your Pascal's triangle, go ahead and do that. Remember, all these notes are available to you on Schoology, okay? And when you do that on your calculator even, you get 210. And that's how you calculate the coefficient of A. Okay? Let's try a few more. So I'm going to give you guys some difficult cases, okay? I'm just going to give you guys a hint for number, something like number 69 in the book. That's pretty hard. Use the binomial theorem to expand and simplify the complex number. Don't be so scared of complex numbers, okay? You know if it's a 3 here, right, it's the 4th row, which means it's going to be 1, 3, 3, 1. If it's a 4th row, it has 4 terms. So you know that's what the coefficients are, okay? They want to know to simplify the complex number. Ooh, it's kind of ugly, right? Okay, how can we simplify this? So let's do it this way. What if we factor out a half? We get -1 plus root 3I cubed. Okay? Okay. That means we're going to factor out a 1/8 because there's 1/2 to the 3rd, right? So 1/8, and you're left with -1 plus root 3I to the cube. Okay? So what I would suggest you do for this one is you leave out the 1/8 as a constant. And then expand this out, knowing what you know. So I'll do the first few with you. You know it's the first coefficient is 1, 3, 3, 1, right? So you know it's 1. You have a 3. You have a 3. And you have a 1. Write the rest of it out. So first one's going to be -1 to the what power? 3rd power, right? And your other term is going to be root 3I to the 0 power plus 3 times -1 square power root 3I to the 1 power plus 3 times -1 to the 1st power. Next one's going to be root 3I to the 2nd power, right? Plus 1 times -1 to the nothing power, root 3I to the 3rd power. And you have all your 3's here, okay? And then you would simplify that and multiply by the 8, okay? So solution should be 1, I think, okay? So check that, number 69, that's how you do those, okay? Not hard, right? All right, okay, well, let's go to part 4 now. Dun, 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 boom.